All right, thank you, Randy, and good morning, folks. As Randy said, my name is Keith Sherburn. I'm a meteorologist at the Rapid City WFO, and I'm going to be starting off this presentation. Then Jordan will pick up where I leave off as we discuss the Quad State Supercell of July 10th this past summer. Now, before we start, I also want to say it's just a pleasure to be here giving us a guest speaker series talk, and also to share the virtual stage with Jordan. He was a coworker of mine at a private company before we both found our way into the National Weather Service. He taught me a lot about forecasting at that job, and he also has some great insight to share here. So the supercell of interest on this day initially developed in southeast Montana, and it produced 2 tornadoes and giant hail across parts of northeastern Wyoming and western South Dakota before it transitioned to more of a significant wind producer across central Nebraska. And as you can see here, most of the reports within this corridor lied along the track of the single supercell, though there were some wind reports of the track's periphery as convection grew upscale from time to time. Now, compared to the SPC convective outlook for the day, the reports generally fell along the transition zone from this enhanced risk over much of the region to a marginal risk farther west. And this isn't meant to call out the SPC's forecast at all, but rather it ties into one of the key topics of the presentation, that both models and the SPC mesoanalysis seem to struggle with the environmental evolution on this day, and also the position of a dry line across South Dakota and Nebraska. Now, many of the slides I'm going to be presenting today will have a split screen of SPC mesoanalysis fields or observations on the left, and then radar imagery on the right through the supercell's evolution. So this will give you a snapshot of the storm structure and associated near storm environment around the same times. So at around 20Z, a few distinct updrafts had already developed over southeastern Montana and northeastern Wyoming, as you can see here. These were showing some rotation at the time and beginning to produce marginally severe hail. At the surface on the left, a dry line can pretty easily be identified across eastern Wyoming. You have 98 over 19 here at Douglas, Wyoming, and similarly hot and dry observations as you go farther to the south and west. Farther to the north and east, as you would expect, a relatively moist, warm sector is in place across western South Dakota and northwestern Nebraska. You also have backed flow across most of that area. And I want to point out a particularly moist observation here at Spearfish in the northern foothills of the Black Hills, which was sitting at 84 over 68 at this time. We're going to be talking more about this, this localized feature later. Also at Chadron, Nebraska, which is in the northwestern corner of the state here, the temperature is at 93 with a dew point of 60 and light northeast winds at this time. So the dry line is still west of Chadron. However, if you look at the SPC mesoanalysis, surface temperature and dew point fields at the same time, they suggest that Chadron's either near or potentially behind the dry line, or at least in this modified air near the dry line, with analyzed dew points several degrees lower at this point than what was actually observed. Ahead of the dry line, there's a corridor with ample cape, albeit still weakly capped, at least according to the mesoanalysis. Note that the cape does increase farther to the south and east, as you would expect, where the low level moisture is a bit more robust. Meanwhile, effective bulk shear at this time is very impressive, with 50 to 60 knots of effective shear magnitudes all the way from southeastern Montana through much of Nebraska. Effective SRH is also generally sufficient, or more than sufficient in some cases, for rotated updrafts, with values increasing again as you get towards southwestern and south central South Dakota, bullseye 400 meters squared per second squared there. So taking all of these ingredients together, the supercell composite parameter shows a generally favorable corridor for supercell development and maintenance from that initiation area up in southeastern Montana all the way through South Dakota and into Nebraska. Now let's look more closely at the ingredients favorable for tornadoes. First, the 0 to 1 kilometer shear vector magnitude is quite strong to the near and to the east of the Black Hills. And as you go towards the Nebraska border, you have a broad analyzed area here of over 20 knots of 0 to 1 kilometer shear. You also have a 25 knot barb here, so certainly sufficient. And similarly, the 0 to 1 kilometer SRH is rather impressive, maxing out at around 250 meters squared per second squared there in southwestern South Dakota. LCLs are also relatively low in this corridor, but this plot brings us back to that point that the analyzed dry line is likely too far east in this particular instance, or at least it's being smoothed out by that relatively coarse 40 kilometer grid spacing of the SPC mesoanalysis. So this might mean, or likely means, that the favorable environment to the east of that dry line is also going to be analyzed too far to the east. And interestingly, D-cape, or downdraft cape, is also quite large across most of this area. So this prompts some questions when you're working the warning desk about what the most likely wind-based hazard is going to be associated with these storms. Is it going to be straight line winds, or is it going to be a tornado event? And early in the life of these supercells, these ingredients altogether would potentially suggest more of a hail and a straight line wind threat. And based on the effective significant tornado parameter, the environment is really only marginal for tornadoes or significant tornadoes across northeastern Wyoming, southeastern Montana, and the northern Black Hills. But as you go farther south and east, the environment appears much more favorable for tornadoes. So at this point, working the warning desk, which I was that day, I'm already thinking that if you can manage to get a discrete supercell in that environment over south central South Dakota, you're going to have a relatively high chance of producing a tornado. Now let's step an hour ahead, and I won't be showing all the same fields for this hour, but I'm going to show a few of the key variables. So first, looking at the surface obs again, we continue to see that you have that localized backing at Spearfish, and you have 68-degree dew points on the northern periphery of the Black Hills. And although it's not shown here, Beulah, which is about 15 miles west of Spearfish in northeast Wyoming, had northeast winds at this time and actually had a similar temperature and dew point. So taken together, this suggests that those local effects near the northern Black Hills are going to be contributing to an environment with much higher boundary layer moisture content and also low-level shear as this supercell approaches. And looking at the reflectivity, you can see that those prior 3 updrafts have all consolidated into one storm at this time. The effective shear fields do show some indications potentially of this localized backing, as SPC mesoanalysis does show a local maximum near the northern Black Hills. However, this isn't really reflected in the 0 to 1 kilometer SRH. So it could be that the effective shear localized maximum that we saw was a coincidence, or it could just be a consequence of the thermodynamic considerations associated with the effective layer. Basically, if you have a little bit deeper cape, you could also be tapping into a deeper layer of shear for that effective layer. And the details of these 3 graphics might be a little tough to see, but the point here is that the localized backing and moistening is not restricted to just one observation, nor at one time. There was a broad area of 65 or higher degree dew points, and also east to northeast flow that was evident across the northern and northeastern periphery of the Black Hills throughout this entire afternoon. And this was identified in real time, especially by looking at those observations we looked at before, Spearfish and Beulah. But admittedly, it wasn't weighed as heavily as it probably should have been in warning decisions on that day. So suffice to say, the local maxima and low-level moisture content and low-level shear undoubtedly in this instance provided a locally favorable environment for tornadoes. So this is certainly something we'll want to keep an eye on in future such events for our CWA. So with these environmental considerations in mind, I want to show the storm's evolution as it approached and moved through this locally favorable environment on the northern side of the Black Hills. So this 4-panel of radar imagery has reflectivity on the top left, storm relative velocity at the top right, ZDR at the bottom left, and then KDP at the bottom right. And all the fields here are at the lowest radar tilt, which is ½ degree from KUDX. So at this point, the supercell is just starting to enter the frame in the top left. But I wanted to point out a clear-cut vertical side lobe contamination signature on storm relative velocity here. This gives the false impression of a very strong couplet in an area where there's not really much reflectivity to adequately sample. So that's something to keep an eye out for when you're working the morning desk. Moving forward a time step, we begin to see some artifacts of a 3-body scatter spike on the southwestern flank of the storm here, indicating that there may be some large hail in the rear flank portion of the storm. If I had correlation coefficient here, it'd be a lot easier to determine that it is indeed a 3-body scatter spike signature, but we were starting to get some large hail reports in association with the rear flank and also the forward flank downdrafts at this point. Now at the lowest tilt here, you can see it is pretty difficult to discern a clear rotational couplet at this time, though there is it's pretty clear convergence ongoing. And note in terms of reflectivity as well, there's this new area of modest reflectivity in the inflow region of the supercell. Moving forward again, this modest reflectivity feature has expanded in size quite a bit and has also strengthened at this time. And in hindsight, it appears that this might actually be a new updraft developing in the inflow region of the supercell. So given the localized backing and moisture pooling that's already evident in this area based on observations, and the tendency for a supercell's inflow environment to be characterized by even higher low-level shear, a new updraft that's developing in this specific location would probably rapidly begin rotating low levels and would likely pose a threat for tornadoes kind of in the shorter term rather than the longer term. That trend continues into the next scan. You could also see a little bit better identification of the 3-body scatter spike signature at this point. You can also see that the rotational couplet is a little bit better defined at this point. Now here, the rotation still appears to be fairly broad, but it is strong and strengthening. The ZDR arc, which can be kind of identified in this area here, this localized maximum of ZDR along the forward flank of the supercell, and the KDP foot, which is back in here, that localized maximum KDP, they do not appear particularly favorably oriented for tornado development in this case. The separation vector in this case was approximately parallel to the motion of the supercell rather than perpendicular. And there's also an apparent disruption here in the ZDR arc. So taking those factors into consideration, it doesn't look like those would support necessarily the potential of tornado genesis in the near term. But that said, that aforementioned rapidly developing updraft that we've been looking at, that might actually complicate the method of looking at ZDR arc and KDP foot a little bit. And stepping forward again, we have a pretty messy picture at this point. It does appear that new updraft has taken over. You have a new forward flank downdraft region as well along the Wyoming-South Dakota state line. The inbound velocities at this point are very clearly strengthening, or they're at least being more adequately sampled. And the KDP foot and ZDR arc signatures are not especially clear. It looks like you're getting a new ZDR arc in association with that new forward flank downdraft, but they don't necessarily provide a whole lot of guidance. In this case, whether we're going to be looking at potential tornado genesis in the near term. Nevertheless, as we step forward another scan, this is the time that, based on damage surveys, a tornado began. So this loop covers the lifetime of the tornado. Here I have correlation coefficient and spectrum width on the bottom instead of ZDR and KDP. As you can see, the Black Hills really were wreaking havoc on the low-level velocity fields, especially early in the tornado's lifetime. And we ended up changing VCPs once the tornado warning was issued. But either way, this was somewhat of an ugly evolution, especially when you're just looking at this ½ tilt. Based on that surging hook echo, we were thinking that this was primarily a straight line wind threat for some time, especially given some of the environmental considerations that the SBC mesoanalysis was showing us before. But looking at higher radar tilts, it does become apparent that the velocity couplet was indeed tightening considerably farther aloft. So at this time, we had no visual confirmation of a tornado, or really even a spotter who could actually see the storm very well, given the terrain. We didn't have any reports of damage either, but based on those velocity trends aloft, a tornado warning did end up getting issued. Unfortunately, it had several minutes of negative lead time at this point. So one of the points of doing this post-mortem is so hopefully we can provide a little bit better service, get more lead time in future such events. So now that the first tornado of the event has ended, I want to zoom back out, look at some of those SPC mesoanalysis fields again for the downstream environment. As before, the radar reflectivity and velocity around the same time, showing it right. At this point, the supercell does look a little bit less organized than what we'd seen before as it starts to approach the Rapid City area here. But the downstream environment is still pretty favorable for both supercells and tornadoes, as we'll see soon. And I want to draw your attention again to Chadron, Nebraska, just to point out that it still appears to be east of the dry line, or at least in some sort of modified flow between the dry line and the warm sector. You have northeast winds at this point at Chadron and a dew point of 59 degrees. So clearly not into that dry air just yet. However, the SPC mesoanalysis, based on the dew point, shows Chadron pretty well behind the dry line. So this poor placement of the dry line is inevitably going to be affecting the other fields as well that are important to determine what's to come for this supercell. So the question is, how can we get value out of guidance like the mesoanalysis or even CAM output when it happens to be wrong? Well, the effective STP for this hour continues to show that the most favorable environment for tornadoes is the east of the dry line, as you would expect. But we established that that's just simply too far east in the mesoanalysis. So if we can mentally correct for this erroneous placement, we can tell that the enhanced corridor of STP should actually be quite a bit farther west. Again, ahead of the dry line, but that happens to be immediately downstream of this supercell. And this is particularly true as you get closer to the Nebraska border. Now, over the next hour or so, the supercell begins to reorganize and starts to take advantage of this favorable environment. As the storm approaches the west side of Rapid City here, we get a glimpse of a bounded weak echo region approaching 25,000 feet in height. Similar B-weir heights were observed as the supercell continued to move southeastward. So you pretty clearly have a very strong updraft at this point, and it's one that persists for quite a while. You could also look at ZDR column height for another basically measure of the same sort of signature here. Now, jumping ahead to the next hour, the storm has moved through the Rapid City area. It's produced a lot of giant hail. We had several reports of over baseball-size hail on the west side of Rapid City as it moved through. It does begin to look somewhat outflow dominant at this point. You see the gust front is noticeably ahead of that higher reflectivity at this point. And then looking back at the mesoanalysis, we see that Chadron is very close to the dry line by this time. The winds now become calm. The dew point is beginning to drop a bit. It dropped about 8 or 9 degrees in the last hour. So it does look like dry line's approaching that area at this point. But again, SPC mesoanalysis continues to poorly represent the position of that dry line, at least the leading edge of that drier air. So as noted before, we need to mentally adjust the SPC mesoanalysis fields to accurately assess the pre-storm environment, in this case, across southwestern South Dakota, because this is the environment that this particular supercell is going to be moving into in the next hour or two. So moving one more hour forward, the supercell is pretty clearly reorganized at this point. No longer appears to be outflow dominant at all. Have kind of a traditional classic textbook supercell look now with nice hook echo, nice inflow notch as well. And it's also now moving into an environment with a considerable amount of mixed layer CAPE, so over 3,000 joules per kilogram of CAPE, according to the mesoanalysis that we've kind of adjusted to account for that misplacement. Also, the effective shear is now up to 70 knots downstream of the supercell. The low level SRH is about 100 to 200 meters squared per second squared. And the LCLs are reasonably low, perhaps in the 1,500 to 2,000 meter range when you account for the misplaced dry line there and misplaced dry air, which really isn't too bad for the high plains. So altogether, the environment continues to look favorable for tornadoes and potentially significant tornadoes across southern portions of South Dakota and getting into northern Nebraska. So fast forward now to 024Z. At this point, given that there is a discrete supercell with a very strong and a persistently strong updraft, moving into an increasingly favorable environment, and also given what kind of happened earlier in the day when the supercell in its early stages moved into a locally favorable environment, I'm actually pretty confident in issuing a tornado warning for this storm. And that's despite having contaminated ZDR and KDP owing to a hail core, which is up radial. You can kind of see it here in reflectivity. The radar is up to the top left here. But I still feel pretty confident, just given the environment that this prolific supercell is moving into. So I'm now going to step forward through the next several radar scans. So the tornado warning is now displayed. At this time, it shows a pink box because the tornado was later confirmed. But at this point, when we initially issued it, it was a radar indicated tornado. Note that that hail core that's up radial, and you can see a recent report of baseball size hail came in. So we were getting some very large hail reports associated with the supercell all the way through its lifetime, up until when it started producing tornado and even afterwards. But this large hail core up radial is also causing some issues with the velocity, causing velocity drop out there. And I'm just going to step through. You can see how challenging having a hail core up radial can make the assessment of velocity trends in terms of the mesocyclone, because many of these slides or many of these radar images here, you can see the velocity just wasn't evident. But as I continue to step forward, you see that we eventually do start to get a little bit better representation of the mesocyclone as reflectivity begins to increase slightly within the inflow notch, and really the core of that hail shifts a little bit relative to the mesocyclone. And once we start to see that velocity near the hook echo and the updraft, we can indeed see that we are getting a strengthening couplet at this time as the supercell approaches this highway between Batesland and Martin. So continuing to step forward here, pretty nice couplet showing up there. That's probably just an indication of the mesocyclone. But as we continue to step forward, we still have issues with the velocity quality down radial from that hail core. At this point, there was a recent golf ball size hail report, but we do get additional baseball and softball size reports as well. And finally, as we start to get closer to the highway here, we do have some storm spotters on that storm. They start relaying us some information. There was not a visual confirmation of a tornado yet at this point, but the tornado did begin around 043Z based on the damage survey. And again, this loop lasts through the lifetime of the tornado. As you can see, we did begin to receive some tornado reports as it approached the highway to the east of Batesland here and ended up crossing the highway actually. We also see during this time a bit better resolution of the mesocyclone and also very strong gate-to-gate shear as the tornado crossed the highway. Getting a visual, as I mentioned, was pretty difficult for spotters. It was shrouded in rain as it crossed the highway here east of Batesland, but nonetheless, our damage survey showed both EF1 tornado damage associated with the tornado, and then a broad area of straight line rear flank downdraft damage as well that occurred farther to the north and west. And there was a broad area of severe or near severe straight line winds associated with this that extended well west of Batesland. You can see near the end of the loop here, there's a gust that was about 55 to 60 miles per hour west of Batesland. And that did cause some damage kind of in the Porcupine area and through that entire corridor. So this was a very prolific supercell and had all of the hazards that you could come to expect from a supercell. So here are some key takeaways through this portion of the storm's lifetime. First of all, this is a worthwhile reminder that sometimes, or maybe even oftentimes, it's going to be necessary to mentally adjust the SPC mesoanalysis to observations, particularly in areas with unique terrain features or in transition zones, because just due to the resolution or the grid spacing of the SPC mesoanalysis, it can really struggle with adequately depicting local effects and tight gradients. And we provide an example here of a fairly high cape environment with a dry line, but this is also a consideration in environments such as high shear low cape environments where you may have just a narrow sliver of instability that can be smoothed out by the mesoanalysis. Second, and this kind of refers to more of a local issue, but it also applies elsewhere, I think. It's very difficult or even impossible for us to get high quality velocity data far from radar and also in areas of terrain. So the question is, how should we address this in future events? And in terms of near terrain, higher elevation tilts might help, like they did in this case, might help provide improved confidence. But you don't have that luxury as you get farther from radar. And I know that's an issue that a lot of offices deal with, is that storms can often occur farther from, or pretty far from the nearest radar. So instead, maybe there should be more focus on the environment and local effects. And this reiterates the importance of a dedicated mesoanalyst that can assist with radar operations in situations such as this. Next, the new ZDR ARC KDP foot research is indeed very useful in providing guidance for potential tornado warnings in some circumstances, many circumstances really, but until the detection of these features can be somewhat automated, this method is still going to be associated with a considerable amount of subjectivity, and its applicability might be limited in some scenarios or situations or even locations, such as far from radar. It might also be limited in a situation such as this, where it seemed like there was a new updraft that could have been disrupting the signal a little bit. And finally, it's possible in many situations to get lead time on tornadoes with discrete supercells just by knowing and having confidence in the environments. Sometimes that and spotter reports are going to be the best guidance we'll have, and maybe the only guidance we'll have for our warning decisions. In other situations, environmental information and other factors such as indications of a persistent strong updraft, which could be based on a beware or ZDR column, or evidence of a rapidly strengthening updraft, either via radar, satellite, or other factors, can help solidify that decision. Ultimately, I think it's really important that we take a step back from warning operations and make sure that we're keeping up with what the environment's doing. So that's all from this side of the storm track. I'm now going to bring in Jordan to bring us home.
Hey, good morning, everybody. My name is Jordan Thies with the National Weather Service in Hastings, Nebraska, and I'm going to be covering the Nebraska portion of this storm. As Keith mentioned, we had at 1Z we had an ongoing supercell that was producing tornadoes in the vicinity of the Nebraska, South Dakota border. But I want to take a step back and kind of reevaluate the mesoanalysis trends that we were seeing with this system as we went into the evening hours. So at 0Z, you could see on the surface analysis, next slide, that we had low pressure in vicinity of Shadron. It was 101 over 46, so with a southwest wind, so certainly behind the dry line at this point. We had a stationary boundary near stretching northwest and southeast across the state of Nebraska from that low pressure down through south central Nebraska and into Kansas. We had a dry line extending south from the low pressure through the Panhandle and into northeast Colorado. And I also want to point out that we had a meso high that had developed over south central Nebraska in response to convection from earlier on in the day. That afternoon, we had some thunderstorms roll through. Still had a decent amount of moisture, but certainly cooler there in the northeast wind there at Holdridge. So we did have a bit more of a stable air mass over south central Nebraska due to that earlier convection. Looking at the upper air analysis, as Keith mentioned, we had pretty strong shear in place, and at 500 millibars, we had a fairly impressive flow for mid-July in this part of the country, about 45 to 55 knots of northwesterly flow, atop about 20 knots of southerly flow at 850 millibars. So not only good directional shear, but pretty good speed shear as well. And next slide, if you look at 700 millibars in the sounding from North Platte, a couple things I want to point out. On the North Platte sounding, we had a pretty impressive capping inversion there, based at about 700 millibars, warm, dry air. Also, temperature of about 16 C. And as you can see in the image on the left, we had a pretty decent thermal gradient stretching northwest to southeast across the state of Nebraska. And it looks like that thunderstorm cluster would tend to want to ride southeast through the state along that gradient, but probably stay east of North Platte because of that dry capping inversion. Also, as you can see on the sounding, there's about 2,200 joules of instability and just shy of about 150 joules of inhibition. So moderate cape, but also some pretty strong capping. Now, comparing that to the 1Z mesoanalysis, you can see it looks like the SPC mesoanalysis was tending to overestimate the cape and underestimating the amount of addition in the vicinity of that North Platte sounding. And as you can see on the right, shear was very strong for this time of year, well in excess of 60 to 70 knots there of effective bulk shear. So decent amount of instability downstream of the ongoing activity and more than enough shear. Looking at some of the hail parameters, we had steep mid-level lapse rates in place, and that was aiding in some fairly significant cape within the hail growth zone, maxing out near 1,400, 1,500 joules just downstream of the ongoing supercell. And so as a result, both the large hail parameter and SIG hail parameter values were fairly impressive immediately near and just downstream of the ongoing supercell. As far as some of the wind parameters, again, we had fairly substantial 0 to 3 kilometer ADE difference, pretty good amount of downdraft cape. Again, maybe it's the placement is a little bit off, as Keith mentioned. But then I want to point out on the low level lapse rates, they were okay in vicinity of the supercell, but downstream lapse rates really decreased owing to that more stable air over south central Nebraska due to that earlier convection. As far as tornado parameters, effective SRH was well in excess of 200 meters squared per second squared, even maxing out maybe even closer to 400 or 500. We had 20 to 25 knots of 0 to 1 kilometer bulk shear. And so no surprise, the effective sig torque right in the vicinity of that supercell at 1Z, pretty high at 2, maybe even maxing out near 3. But as you can see, the sig torque values certainly tended to drop off with southeastward extent into the state of Nebraska. So this kind of begs the question, what's next? What can we expect from this activity as it moves into Nebraska? Certainly there was the short-term tornado threat, high SRH, low-level shear, in combination with an ongoing supercell. But it looked like that with time, increasing surface space inhibition would likely limit the downstream threat area both spatially and temporally. Overall, the environment remained favorable for large hail and damaging wind. Wind threat looks like it could be somewhat dependent on the ability to generate a cold pool. And overall, it looks like the intensity of this activity would probably decrease in a few hours, given the increasing inhibition and the movement of this activity towards and into areas that had already been worked over and not necessarily recovered from earlier convection. So looking at the radar loop from about 37 UTC to 239, you can see the supercell as it was near the Nebraska South Dakota border. Still very impressive, producing very large hail, tornadoes. But fairly quickly, as it moved into Nebraska, it began to transition, became a bit more outflow dominant, and certainly looked like we were transitioning from a more discrete supercell to more of a QLCS type structure with maybe some embedded supercells, particularly on the western and southwestern flanks. Moving ahead to 3Z, you can see the activity still lied within a decent instability axis, about 2,000 to 2,500 joules per kilogram for a mixed layer cape, locally as high as about 3,000. But as you can see, both the instability decreased and the inhibition increased with southeastward extent there into central Nebraska. And it looks like we were already starting to see some weakening and trends in the convection becoming a bit less organized, particularly in that area from Ainsworth up to north of O'Neill. But we still had a pretty good supercell immediately northwest of the North Platte radar site, KLNX. Looking ahead now 3Z to about 4Z or a little bit after, you can see a very rapid decline. We're now past sunset. Activity pretty quickly lost organization and intensity. Even the supercell structure that was near the North Platte radar site was also decreasing, becoming less organized. And overall, this is generally what was expected based on what we saw from the mesoanalysis data. And looking at the 4Z mesoanalysis radar, again, really no surprises to us at this point. The activity was much weaker, much less organized. The instability had decreased further, now about 1,000 to 1,500 joules of mixed layer cape, and the inhibition was well in excess of 250. Also want to point out that we did have a bit of a thin line indicative of some outflow from Tryon to Stapleton toward Broken Bow and even towards Ford. But as you can see, it was well out ahead of the convection, and there certainly wasn't any reflectivity gradients associated with this outflow. At just shy of 430Z, turn your attention to Ord, as this was when things began to change a bit. You can see the thin line on radar indicative of that outflow had already passed. It's from Stapleton to Broken Bow to just south of Ord. And the echotops associated with the convection moving in from the north were only about 30 to 35,000 feet, and had been seeing a decline over the last 30 minutes or so. Now it's worth pointing out that the North Platte radar was probably not a good angle for northerly wind gusts, northerly outflow with this convection. And the Hastings radar, which is off the screen down and to the right, while a much better angle, we're pretty far out away from it. So it's looking at about 7,000 to 8,000 feet above radar level. Also within this yellow circled area, it's pretty sparsely populated. It's the Nebraska sandhills. There's really not much but cows and pasture. There are a few towns, but they're small. And there's really no automated upstream observations in this area upstream of Ord. We're after 11 p.m. Central Daylight Time, so we're getting fairly late into the evening, and so the chances of getting any real-time observations from this area really are pretty low. Well, about this time, we get about 4:30 Z, we get a 63 mile per hour wind gust from Ord, Nebraska. This was not expected. And I guess a little background on Ord. It is an ASOS, and it's in the middle of central Nebraska, so it's pretty wide open, really nothing but pasture and cropland. This is a site that tends to overachieve when it comes to north and northwesterly wind gusts. We know it, we try to take it into account, but for whatever reason, it seems to overachieve. It's in the North Loop River Valley that extends up towards Burwell. There's pretty steep hills on either side of the valley, so perhaps maybe some wind gets in the valley and funnels it in towards the airport observation there. But again, for whatever reason, it tends to run high, but we had a 63 mile per hour wind gust, and again, it was not expected. So we're a little unsure of what's going on at this point. We need to dive into the data a little bit more to figure out what's going on. So looking at the 500 millibar charts, you can see a shortwave there in southeast South Dakota, a bit of a speed max there, right over that cluster of thunderstorms, about 50 knots there at 500 millibars. A low-level jet had developed, 35 to 40 knot southerly low-level jet, nosing in from southwest Nebraska into central Nebraska. But this was largely west of where the recent wind report had occurred. And looking at the 2-hour surface pressure change, you can see maybe the hints of a meso high, possibly, maybe trying to develop there near and north of O'Neill, but the overall pressure changes were certainly not impressive or anything to worry about at only about 1 millibar for every 2 hours. So looking at the radar from about 4:30 Z to 5 Z, we did issue a warning, felt we need to get something out. I was working on the warning desk for this midnight shift, and did issue a warning, felt we need to get something out to cover that wind gust. And once we changed the PRF and got rid of some of that bad velocity data, as the activity continued to shift southeast, get a little bit closer to the radar, became a little bit more confident in that warning, particularly as the activity got towards Loop City. You can see an enhancement in the velocity, and you can also see on the reflectivity on the left, a bit of a secondary surge, an outflow there, kind of another thin line of reflectivity, and that was much closer to the stronger reflectivity cores. Now, all of this was going on despite a situation in terms of instability and inhibition that, again, kind of left us scratching our heads. Instability was continuing to decrease, the inhibition was continuing to increase, and overall the thermodynamic environment certainly did not seem very conducive for strengthening convection, given what had occurred and what we were seeing on the mesoanalysis. The kinematic environment certainly was still on the strong side. Again, looking at 850 millibars, low level jet, still present, nosing into central Nebraska, but again, generally displaced a bit further west from where the wind gusts and thunderstorm strengthening was occurring. However, on the 2-hour surface pressure change chart, this is what kind of started to pique my interest. It looked a little more impressive, a little more indicative of a meso-high developing there near O'Neill. According to this, the surface pressure was getting up to around 1,019 millibars, and the 2-hour surface pressure changes were a bit higher. The mesoanalysis implied about 1 to 2 millibars for every 2-hour pressure rises, but if you look at O'Neill itself, the raw data, you could see the pressure changes were actually much higher, and they were on the order of about 8.2 millibars for every 2 hours, so about 4 times higher than what the mesoanalysis indicated. And at this point, it was becoming quite a bit more obvious that we were dealing with a meso-high, and that the mesoanalysis is not quite capturing the local effects of this very well. Going forward, 5Z to 6Z, this is about midnight to 1 a.m. local time. The activity continued to maintain its intensity as it shifted southeast towards the biggest city in our CWA, which is about Grand Island, 50 to 60,000 people. And if anything, it looked like the velocity was peaking just prior to moving into Grand Island itself. Also, on the reflectivity on the left side, you can kind of see some signs of maybe a bit of a supercell structure reemerging, with a bit of a hook to it there on the southern flank. And overall, this activity was keeping up with the outflow fairly well, at least to the Interstate 80 corridor. Looking up to the 5.1 degree slice, you can see the equitops had briefly spiked to about 50,000 feet. So again, owing to that at least short-term intensification and organization, and a broad mesocyclone had emerged at about 28,000 feet there to the northwest of Grand Island. So we had certainly seen an uptick in the organization of this activity and kind of a reemergence of a supercell structure there in the southwestern flank of this activity. Looking up to the 6.4 degree tilt, it was about a 70 to 80 knots inbound, max there at about 30,000 feet. Again, this is probably indicative of that speed max there associated with the 500 millibar shortwave. So looking at the same surface pressure data for Grand Island as it moved, as the gust front and activity moved through Grand Island. So very similar trends. It was actually even a little bit higher, about 9.2 millibar pressure change over a 2-hour span. And again, this was still about 3 times higher than the mesoanalysis indicated. And again, this is all going on despite a thermodynamic environment that really was not too supportive for this type of activity. Finally, looking at the activity in the 6 to 7Z time frame, we saw a very rapid decline in both coverage and intensity. This is what we were expecting several hours ago, and overall saw a pretty rapid decline. We were still seeing some wind gusts around 50 miles per hour, but the severe gusts declined fairly quickly, and so then we allowed the warnings to expire. As far as the storm reports, you can see we transitioned from some sig hail and tornadoes there in south central South Dakota near the Nebraska state line to mainly wind after 1Z. The general weakening trend had continued, but it still remained severe into south central Nebraska. You can also see some severe wind reports in northeast Nebraska in the Norfolk area as well. Stepping back, this whole event produced about a 500-mile-long path of severe reports. It started about 20Z in southeast Montana, ended about 6Z in south central Nebraska. It lasted about 8 hours, and the most significant severe reports occurred between the Black Hills and the Nebraska Sandhill. So, takeaways from Nebraska, much like Keith, the mode transition from Supercell to QLCS, maybe a bit of a hybrid QLCS with tail end Supercell. The kinematic environment remained favorable, but the thermodynamic environment suggested weakening due to increasing inhibition, or at least the convection becoming more elevated. And was also tracking toward an area that had been worked over by convection earlier on in the day. Nonetheless, the meso-high managed to develop over north central Nebraska, which locally increased the pressure gradient force with this line of thunderstorms as it moved into central Nebraska. It also, perhaps enhanced or aided the kind of reinvigoration of that supercell on that southwestern flank. But again, takeaway from this event as it came through Nebraska, similar to Keith, we actually didn't plan this. When he asked if I would take the Nebraska portion of this, we had actually we never really planned to come away with the same takeaway point. Just so happened that it worked out that way. The SPC mesoanalysis, great tool. This is not a knock on it. But for kind of different reasons, this is an illustration of how I need to occasionally QC the data, and especially on finer scales. Just like it wasn't quite capturing the dry line placement earlier on in the day, those finer scale details, it was seemingly struggling to capture the finer scale pressure rises associated with the meso-high development in central Nebraska, as ultimately the pressure changes were much higher and much faster than what the mesoanalysis indicated. So again, just a reminder to occasionally QC the data, especially if it perhaps is not making sense. So that's all I got. I will turn it back over to you guys.